Now, to talk about the third pattern, instead of hearing me talk about it, I think we should show something at this point. So we're really excited to invite Tracey Thorleifson to the stage from G2 Integrated Solutions. Tracey.
Thank you, Brian. You know, I just realized as I was walking out here that we've got about 2 orders of magnitude more people than the first time I did something like this about 20 plus years ago. Anyways, I'm really excited to have the opportunity to share with you our experiences in using insights for ArcGIS to understand complex data sets. And this morning we're going to talk a little bit about risk analysis results for a pipeline. Pipeline risk analysis is really important to operators for the safe operation of pipeline assets. An understanding of pipeline risk also entails an understanding of the threats of concern that could potentially cause a failure along the pipeline at any given location. And by understanding those threats, operators can go ahead and craft prevention and mitigation programs to curtail those threats, as well as select appropriate assessments to inspect the pipeline. Now, the pipeline risk analysis algorithms that operators use are industry standards driven and generally consist of 2 main components. Total risk is usually a combination of probability of failure and consequence of failure. Now, when we look at probability of failure, we're concerned about 2 main categories of threats. Time-dependent threats, these are things that get worse over time, include things like external or internal corrosion, and also time-independent threats. So these might be things like excavation damage caused by construction operations in the right-of-way. On the consequence of failure side of it, we're generally concerned about understanding what is going to occur, what the consequences of a release will be if we do have a release from the pipeline. For natural gas pipelines, the things that we're primarily worried about are people, right? The threat of ignition of the product. For hazardous liquids pipelines, we also have to take into account potential damage to the environment, as well as drinking water resources and navigable waterways and things like that. Also, on the consequence of failure side, we're worried about service interruptions. If thousands of customers have their gas turned off in the middle of winter in Montana, that's generally considered a bad thing. So by understanding these 2 things together, we can get a picture of overall risk. As you might imagine, these models become very complex, with dozens, if not upwards of 100 variables contributing to that final risk score. So understanding what's actually driving risk is sometimes a daunting task. Historically, we've used tools like risk alignment sheets or dedicated risk viewers to explore and understand data, but they tend to be more static and in many cases don't adequately put things in spatial context. So when Insights for ArcGIS was released in ArcGIS Online in December of last year, we wanted to see if that was going to be a valid and usable tool to explore risk analysis results. So let's go ahead and take a look. So we're looking at a risk analysis data set. This analysis data set consists of approximately 60,000 individual risk segments calculated for multiple pipeline assets. And for this analysis right now, I've got it filtered so that we're looking at just 1 line. And there's about 4,000 different points in all the graphs that we're looking at. Now, this is a complex data model, so if we just kind of scroll down, what you can see is that I've got upwards of 100 different attributes contributing to the final risk score. So what we want to do is we want to understand what's actually driving that risk. Now, I've got a map card displayed here in my analysis model template, and it's colored such that darker blues are lower risk segments and lighter blues are higher risk segments. Now, when we look at risk on a particular asset, the first thing we want to understand is the distribution of risk values. And so I've created a histogram of risk results for this particular line, and what we see is a normal distribution. That's actually a good thing, because if I can address this long tail of higher risk segments, then that'll have a significant impact on the overall risk for the pipeline. I've also plotted total risk in a profile plot using a scatter plot type of display. And what we're looking at here are the risk values plotted along the length of the pipeline. So starting at a cumulative measure of roughly 0 and going all the way out to 600,000 plus. Relative to the map, that 0 point is up here in the northeastern corner, and the 600,000 plus point is down here in the southwestern corner. Now, as I look at this profile plot, my eyes are immediately drawn to these high-risk segments. Right? We've got a few bad actors out here on this line, and if I can understand what's going on with those high-risk segments and potentially mitigate them, then I can really improve the overall situation on the pipeline. So let's go ahead and let's just select those points and see if we can't get a better understanding of what's actually happening here. Now, the really cool thing about Insights for ArcGIS is that as I update a selection on one card, it's updated on all of the other cards that I've got in the analysis template. So everything is being updated across the display. We can see these high-risk segments over here on the map. And if we go ahead and we start to dig down into that data a little bit, recall that total risk is a function of consequence or frequency of failure combined with consequence. And we see that we've got both a high frequency of failure and high consequence of failure here. Not unsurprising, given that those are the worst segments on the line, but not always the case. If we look at them on the profile plots, what we see is that, yes, we do have an elevated frequency of failure, and we do have elevated consequence of failure. So again, no surprise. Now, we can't really do much about consequence of failure other than reduce pressure and reduce throughput on the line, or actually physically move the line. But if we can understand what the threats of concern are that are driving this frequency of failure and mitigate them, then we can go ahead and take care of the probability of failure. So digging down, if we look at external corrosion for those segments, what we see is that external corrosion doesn't really appear to be a problem here. It's just right in track with the lower values on the line. If we look at internal corrosion, again, what we see is that internal corrosion doesn't appear to be a threat for these segments. If we look at stress corrosion cracking, which is caused by cyclical fatigue on the pipeline, what we see again is, hey, it doesn't look like we have an issue here with stress corrosion cracking. Similarly for geohazards, this is outside force caused by things like earthquakes or soil creep or stream scour. Again, doesn't look like a particular concern for us. But if we look at third-party damage, hello. These segments have a very high likelihood of suffering third-party damage. So that's interesting. If we scroll over a little bit, we see that we also have an elevated risk of sabotage. These two things often tend to go together, so not unsurprising, but again, an elevated risk of sabotage. And then finally for these points, we see that we have an elevated likelihood of incorrect operations causing a problem. So with just a few clicks of the mouse, I've been able to understand the threats of concern for these highest risk segments on the pipeline. Let's see if that makes sense in spatial context. So what I'll do is I'll go ahead and I'll zoom in to that selected set of points. And actually, let's zoom out just a little bit. And what we can see is, yeah, that section of the line is right next to a major road, and it's actually in a common right-of-way with other assets. So that explains our exposure to sabotage and third-party damage. And in fact, if we zoom out a little bit, what we'll see here is that we're in a highly populated area. So if we do have a failure, there's likely to be very unpleasant consequences. Right? So understanding what these threats of concern now, I can now as an operator go ahead and take steps to mitigate those particular problems along the pipeline and hopefully reduce overall risk. Now, the really cool thing about all of this is that I put this together in a very short period of time. Insights is extremely easy to use, and its availability in ArcGIS Online means that it's accessible to almost anybody for a very low cost. But even more importantly, it's fully integrated into the overall Esri platform. So it becomes accessible to everybody else in my organization who needs to see it, or even people outside of my organization if I choose to show it to them. So, Insights for ArcGIS with pipeline risk results. Thank you.
Oh, that was really impressive. Thank you, Tracey. Fantastic. Well, that's a nice segue. Obviously, the technology, as I said before, is critical to implementing a location strategy. And what we just saw illustrated from Tracey was a great example of applying the latest tech with a powerful back end to simply solve a basic business problem. So let's get an update on the technology. Evolving and emerging capability in ArcGIS is really fundamental, and we see that this is creating new opportunities for business impact across the board. So clearly, this is a technology show. We want you to soak up the latest news and information on where we are and where we're going so that you can learn how to apply that to your business problems. One thing that's really central to the way we're thinking about the technology at Esri is this idea that ArcGIS is both a comprehensive GIS platform as well as an online simple mapping and location platform. So we're really thinking about two ends of a spectrum. ArcGIS Enterprise, deployed as the most robust and powerful GIS on the planet, and then simple applications and use cases that we can supply to the entire business, whether they know what GIS means or not. We're advancing on both fronts, and I want to share some of that. At the heart, data management and compilation, powering the systems of record that underlie everything that we do. There's lots to talk about here in improvements in editing and data management, but two things I'd like to highlight. ArcGIS for pipeline referencing, our focused tool set for managing linear referencing along pipelines. A lot of work is going on to continue to improve and enhance the capabilities of that, integrated into Pro. And in the CAD and BIM integration area, Esri and Autodesk have announced our alliance, and we're working very closely together. And we believe that this will be a positive benefit to all of you as we build seamless integration between the beautiful design tools that Autodesk brings to bear and the overall GIS infrastructure that Esri has. We think about it as the world's leading design, for example, in a city, building design, each building designed with AutoCAD, shared with the GIS to create a smart city view of the entire space. We're looking forward to seeing what you all do with those integrations. Of course, CAD and BIM data are well observed and interacted with in 3D. Esri continues to make progress on 3D on all fronts, including LiDAR, oblique imagery, GIS data in natively 3D formats and visualizations, and full 3D photogrammetry. We're also continuing to work hard on exploratory data analysis and visualization. Insights is our flagship product there, and as you saw from Tracey, tremendous work connecting the powerful backend of the enterprise GIS with a simple location platform to quickly analyze and share results. This is creating a new language, a new spatial BI activity. Of course, spatial analysis doesn't stop with insights. We're making improvements and additions to the technology across all parts of the stack. One area that I really like to highlight is the R bridge and the ArcGIS API for Python. These two elements are enabling data scientists to connect to the Esri stack and get all sorts of productive work done, bringing two communities together with the most robust technology. As we discussed earlier, field mobility is an essential and growing area. Esri has a handful of flagships applications in this area, from Explorer, Workforce, Navigator, and for field data collection, Collector, and Survey 123. We continue to make enhancements and improvements to these fundamental capabilities. In addition, we're always enhancing our developer APIs and our web app builder technology for people who want to extend or build custom applications for field mobility and beyond. Imagery, as you know, has been a critical part of a GIS ever since the beginning of this technology. We've been continuing to put capability into the platform for imagery to the point now where we have a complete system for imagery capture, management, analysis, publication, and sharing. It's not just about nice base maps anymore from imagery. It's about insightful analytical products in near real time from all different kinds of sensors. Of course, real time is growing just about as fast as anything right now. With the proliferation of IoT information, with all the business cases around tracking things that move and integrating sensor information, this is an area of real growth in the market and an area where Esri is putting a lot of time and energy. We're working on the scalability, performance, and elastic backend support within our real-time technology. We're increasing our ability to take in different types of sensor feeds. We're investing in relationships with the IoT cloud providers and integrations natively with some of those stacks. So it's an exciting area, whether you're looking to analyze data in real time through streams, or whether you want to do big data analytics against massive amounts of data assembled and at rest. Both use cases we're working on with significant effort. you.